Welcome. It's an honor to be here with you all today. My name is Thomas, and I'm a tech lead on the Firebase team. Though I'm not actually part of the Firebase Cloud Messaging team, I'm here today because push notifications is an important part to me. I spent 3 years away from Google. I took time away to join a startup that was building mobile applications, or helping it make it easier to build mobile applications. We thought we could empower developers by letting you focus on the technology you wanted to build or the features you wanted to show, rather than the technology that supports it. That startup was actually Parse, where I was the lead developer for Parse Push, one of the top third-party push providers in the world. So that's why I'm here today, because a year ago I rejoined Google to help the Firebase team build the next set of tools and help you build a more successful app. And this year, Google released a massive expansion of Firebase. Firebase is now an integrated suite of products designed to help you build your app, grow your user base, and earn money. And as we revealed this, we said that Google Cloud Messaging is integrating with Firebase. And over the last year, it's been my great pleasure to work with that team. So today, we're going to cover the history of Google Cloud Messaging and why they're now part of the Firebase team. Then we're going to go into some of the technical details: how you can register your devices to receive messages, how you can add custom code to handle those messages, how you can manage who should receive the messages, and then how you can use Firebase notifications to manage large campaigns of notifications to your users. Now, if you are an app developer, especially an Android app developer, you've almost certainly heard of Google Cloud Messaging. It is the standard way for sending updates between a client and server device, especially on Android. In 2013, Google added support for Google Cloud Messaging on Chrome. And in 2015, we added support for iOS as well, so that you now had a single platform that could reach mobile and web devices. Now, we believe two of the most important aspects of a messaging service are reliability and performance. GCM is extremely reliable. Our protocol makes sure that we deliver every message that you intend to send, and that we honor the parameters you specify. And GCM is fast, too. For an online device, our average latency is 65 milliseconds, and the 95th percentile latency is just over 150 milliseconds. So we believe this is why Google Cloud Messaging is an important part in so many applications across iOS, Android, and Chrome. Today, we are powering more than 1 million applications installed across over 2 billion devices. And we're actually sending over 2 million messages per second. That adds up to over 170 billion messages per day. And it's amazing to watch these numbers continue to grow. And remember, Google Cloud Messaging is a cross-platform solution. So you can use one API to reach your iOS, Android, and Chrome devices. Now, meanwhile, at this year's Google I/O, we announced the major improvements to Firebase. That Firebase is now an integrated suite of products designed to help you build your app, grow your user base, and earn money. And these qualities of Google Cloud Messaging, being cross-platform, mobile-first, reliable, and performant, are things that we stand for in Firebase. So at Google I/O, we announced that Google Cloud Messaging would be rebranded as Firebase Cloud Messaging. Firebase Cloud Messaging is the new name for the service that you've come to rely upon. It is a cross-platform network for sending messages between a device and a server. We believe that Firebase Messaging can help provide a more integrated experience to make your life easier as a mobile developer. Now, one of the most common ways people use Firebase Cloud Messaging is to create a notification. A notification is a message that targets a specific, often large set of users and tries to drive them to action. For example, you might have an app that says that the tickets for the festival you bought is tomorrow. Come back and check out the final lineup. And there's a good reason people love notifications, because some studies show that users who opt into notifications are more than twice as likely to open the app and have almost 3 times as long of retention. But too many notifications can have the opposite effect. If we send 10 messages to a user every day, they're likely to silence notifications altogether or even uninstall our app. So on top of Firebase Cloud Messaging, we've built Firebase Notifications. Firebase Notifications integrates with other Firebase products to help you carefully select your audience and measure your engagement. With Firebase Notifications, you carefully plan the time to send your notifications, the audience who should receive your notifications, and you can measure how effective your notifications are. Now, because Firebase Notifications builds on top of Firebase Cloud Messaging, there's only one set of instructions to get started. So let's look at how we get started with both products. But before we begin, Google Cloud Messaging supported iOS, Android, and Chrome. When we announced the rebrand of Firebase Cloud Messaging, we also announced that we're supporting Web Push as an open web standard. We also released C++ SDKs for iOS and Android. Since we're limited on time today, we're just going to focus on Java for Android and Objective-C for iOS. So with the new Firebase SDK, we've worked hard to make sure the registration process is as easy as possible. You'll notice a common pattern in our SDKs. We will auto-register the tokens with the Firebase Cloud Messaging. The new library will take care of automatically handling connection or other errors and backing off as appropriate. If you want to integrate with a third-party push service, you'll need to give them the registration token used to target your device. And you can get that with Firebase instance ID.getToken. We will send updates in the background if that token changes, which we'll also show you how to do. So first, you'll need to add the Cloud Messaging SDK to your Android application. In Firebase, we offer small SDKs for each feature. That way you can keep your applications small. This is a dependency that you'd have to add to your Android app's build.gradle file to get Cloud Messaging in your app. Next, we can look at our Android app manifest. If you remember Google Cloud Messaging, you may remember having to add these permissions to make sure that your app is secure. You don't have to do that anymore. See, we now use the manifest merger to make sure that the correct permissions are added to your manifest without you having to do any work. And this is just one of the things that we've made to improve the experience. Now, if you're staying in the Firebase ecosystem, you're actually already done. You've registered your device to receive messages. If you're integrating with a third-party service, though, you'll need to make sure you give that service your token. To do this, you'll need to implement a Firebase Instance ID service. You do this in Android by declaring your service in the Android app manifest and then implementing it. Now, this class is so easy, I can actually add it on the same slide. First, we're going to extend the Firebase Instance ID service and implement on-token refresh. This will be called both when we have our first token and whenever that token changes. Then we call getToken on the Firebase Instance ID service and give that token to our third-party service or our own backend if we're using our own custom code to send notifications. Now, to integrate with iOS, we're going to need a certificate from Apple. You can get the certificate on developers.apple.com, and you're going to want to add it to your Firebase console in console.firebase.google.com. To do so, we're going to go to our project settings page. From there, we'll go to Cloud Messaging. This is where we can see all the information to configure Cloud Messaging for our project. First, we'll notice that we have the iOS section. This is where we upload the certificate that we got from Apple. By uploading that certificate, we can now use the Firebase Cloud Messaging API to reach our iOS devices. Next, we'll notice our project keys. This is what you'll use if you want to write your own backend code for sending messages, or if you want to integrate with a third-party service. And finally, on the left, you'll notice a notification section. This is where we'll end our talk. But back to our client code. If you're using CocoaPods to manage dependencies in iOS, this is it. This is all you have to add to your pod file to add Firebase Cloud messaging. Now, it's so easy because we use swizzling. This means that we inject our code into your iOS app's app delegate. If you don't want to use swizzling, you can disable it through your appinfo.plist. Now, if you do so, you'll need to make sure you call the messages send APNS token or set APNS token and app did receive message manually. Now, just like with Android, if you're integrating with a third-party service, you'll need to make sure you give that service your tokens. In Android, we listen to events with a service, but with iOS, we listen to notifications with the NS Notification Center. This event is fired anytime we get a new token, whether it's the first token or the token is changed. So we can provide one implementation that will make sure we always have the correct token in our backend server. Now, what if you already have an iOS app? You're already using push notifications, but you aren't yet integrated with Firebase. You don't actually have to wait for your customers to download and update. You can import these tokens on the backend. Your server can send us your existing APNS tokens that you use, and we will give you back new Firebase Cloud Messaging registration tokens. From there on, you can use those tokens to use the Firebase Cloud Messaging APIs. So here's how. You send a message post to the batch import API. You give us your application ID and a series of tokens. We will send back a list of all those tokens, the FCM registration tokens, and the registration status. So now that we've registered our devices to receive notifications, let's look at how we handle those messages. Well, if all you want is for your application to show a notification when you're in the background, you're already done. When you register your device with Firebase Cloud Messaging, your app will automatically display notifications when your app is in the background. But what if you want something more? Some messages don't include a notification. Instead, they tell your app that there's fresh content that needs to be downloaded in the background. Or sometimes you have a bit of both. If the app is in the background, you should raise a notification. But if the app is in the foreground, you have a more subtle or integrated way to get the user's attention, like highlighting a game board. In this case, you want to add a custom handler. And if you're familiar with GCM, that's great because it's the same APIs. You'll define another service to handle a new event. In this case, it's the messaging event. And this is what that class looks like. You extend the Firebase messaging service and overload the onMessageReceive API. From there, you can read the remote message parameter to get anything you want about that message, what its contents are, who it was sent from. You can log it, create a more detailed notification, an interactive notification, or change your UI more subtly. Now, in iOS, there's a standard method on the application delegate. It's called application did receive remote notification fetch completion handler. And if you implement this, you can add custom code to how your application manages notifications. The second parameter, user info, is an NS dictionary. It's a key value mapping of everything that was in that notification. And in iOS, it lets you pause the application and download more information in the background before actually displaying the notification. You can tell iOS that your app is ready to display the notification by calling the fetch completion handler passed to this method. So we've learned how easy it is to create custom and engaging experiences for our notifications. Next, let's look at some ways we can target them. As you may remember, last year at I/O, we announced topics messaging. It's a simple API to publish one message to a large number of users, and it's a great way to target users interested in a common topic. You just publish a message, and we make sure we deliver it to all devices that have registered for that topic. Originally, we launched this with a limit of 1 million subscribers, and many of you asked for more. So we've listened, and this year at I/O, we announced that you can have topics with unlimited subscribers for a single topic or for all the topics across your application. A word of caution when using topic messaging. One, since we allow you to send out messages to a large number of subscriptions, be careful when you initiate these large fanouts to many users. If you publish too fast to topics with too many users, we'll give you an error telling you to try again later. And you can read more about this in our documentation. Also, keep in mind that if all of these devices are going to turn around and speak to your server needs to be ready to handle that traffic. So subscribing and unsubscribing from topics is simple. It's just a single line of code in iOS or in Android. Now, because topics are fast, you might want to replace any backend code that you have that has a similar concept with topics. So for that, your backend can use the REST API to subscribe devices to topics manually. Additionally, if you're trying to migrate existing backends to use topics, you can use the batch API to import all of your existing tokens into a particular topic. So at a high level, you could just say to and your topic name, and that's how you send a message to everyone in a topic. But what if I wanted to send a notification saying that Google Cloud Messaging is now Firebase Cloud Messaging? Would I send it to my Google topic or my Firebase topic? Well, as of I/O, we have a new API, condition, which will allow you to combine topics. So now you can say, I want to send a message to anyone in Firebase, oops, I apologize for the transition error there, Firebase or Google. And if I'm subscribed to both, I'll only get one error, or one message. Similarly, you can also use and if you wanted to make sure you talk to people only who are interested in Google and wanted to reach Seoul. Now, over the years I've worked on notifications, I've noticed that most customers have one of two use cases. Transactional notifications respond to an event in your application. For example, if I have a Go game, when I place a piece, my backend will send a notification telling my opponent it's their turn. For this case, we have the REST API, which we've already shown you a bit of. The second is campaign notifications. It's when I want to send a large blast to a number of users. Campaign notifications can dramatically improve our engagement or cause a lot of problems. And that's why we built Firebase notifications. Because with any notification, we need to be careful to target the notification correctly. We need to plan when we send it, who we send it to, and what the message is. Because when we get this right, we get the user's attention and get them to act. So to help you get this right, we have to understand our users, and this is why we integrate with Firebase Analytics. Analytics helps us better understand our users by letting us use the attributes or events they've encountered to define audiences. Audiences are used to either drill down deeper into our analytics panel or to re-engage those users with notifications. And after we've sent a notification, we can come back to Firebase Analytics and see how those customers have reacted. So in our notifications panel, you'll find a simple UI right here for creating notifications. It's simple, but it's very powerful. You can use it to target the right users, using either the topics that we mentioned earlier or information about analytics. You can also use this panel to make sure you have the right context. For example, analytics tracks the native language for that device, so you can make sure that your Japanese users aren't receiving Korean messages. You can also target the time zone, and I love that little checkbox, recipient time zone. You can use this to make sure that you say the message should be delivered at 9 a.m. according to the user's time zone, and not wake them up based on time zone differences. Now, if you wanted to add a custom handler, that handler might need extra information. And under advanced options, we allow you to provide extra information. For example, you can have a dynamic link that will take the user to a sale, or a coupon code that can be applied automatically to provide a discount. And finally, a notification should have a goal. With Firebase Analytics, you can define events as conversion events. These are the events that you're trying to drive your customers to. And with Firebase notifications, you can pick the conversion event that you're hoping your notification will influence. Now, the campaigns that we send with notifications integrate back with analytics. When I click on a finished campaign, I see this funnel right here. I understand how many notifications have been sent, how many have been opened, and if I defined that conversion event, how many conversions have taken place. And the integration is even deeper than that. If I go to the notification opened section in the Firebase Analytics, I can pick an exact notification campaign and restrict my entire my entire analytics panel to just the people affected by that campaign, which lets you do some very powerful analysis. So we took a deep dive at cloud messaging and Firebase notifications. These are two products that I think will greatly help you create more engaging applications. But don't just take it from me. Here's some testimonials from partners who have already integrated with cloud messaging and notifications. The first is Le Figaro, the oldest French daily newspaper. They talk about how trustworthy and reliable cloud messaging is. You either grow your team like a giant hydra, or you rely on trustworthy tools. Firebase Cloud Messaging falls into the second category. Next, we have Quaver. This is an app that helps you develop music and collaborate with other musicians. They talk about how easy it is to get started with cloud messaging. Switching to FCM is simple. We integrated the cloud messaging essentials in one afternoon, knowing that notifications would be delivered instantly. And on the Firebase notifications front, we have BusBud, which help you book tickets, and they use notifications to announce new routes and discount codes. They found it really easy to integrate with Firebase notifications while still allowing them to customize the experience for their users. They called Firebase notifications a turnkey console that handles all the plumbing. You're up and running in moments, re-engaging users and providing them with timely, tailored information. And finally, we have a local studio, Malang Studio, a mobile developer app group in Korea, which uses Firebase notifications in their latest app, Chudae, which helps couples celebrate their anniversary. They have users around the world, and they use Firebase notifications time zone feature, so they don't have to worry about waking users up. They said since using the time zone feature, users no longer complain about receiving notifications after midnight. So we're excited to see what you build with Firebase Cloud Messaging and notifications. For more information about these, you can check out our documentation at firebase.google.com, or you can reach out in our support forums. Please let us know how you're using these products. Let us know what you enjoy, what we can do better, and what you want to see next. Thank you very much.